Okay, so I'm going to make this little video to help you with this part of the lab, the Tsunami Lab, and hopefully answer some of your questions about Google Earth. So for sure, if you come to this lab, you should always watch the little videos on all the labs because they should help you kind of get over some of the difficult spots or potentially stuff that's a little confusing. But once you get into the lab here, what we're asking you to do in this first question is to actually plot some points in Google Earth. So a lot of times in the labs there'll be a file. It'll say click here to download the file. The file will get downloaded and then you'll open it in Google Earth and it'll propagate that data into Google Earth. Here I want you to put some data in Google Earth yourself. What these are, that you're looking at in the chart, are longitude, latitude. So there are a pinpoint location on the map and they're describing how far inland the tsunami wave traveled. So when we plot some of these points that you see here, you can put a little pin and then we can measure the distance from the coast, right, where the water meets the land, to the pin, and that'll tell us inundation, how far inland the wave traveled. The run-up height that you're seeing here is the elevation above sea level, so kind of the height of the wave. We also want to know how far inland the wave traveled. In some places it traveled very far inland, other places not so far. But we can see that by plotting these points. So in order to easily plot these points, you can just highlight the longitude, latitude in your little canvas page here, right, on the lab, and you're going to right-click, press copy, come to your Google Earth, and in the top search bar here you can right click and paste and then just do a search, and don't do anything, let Google Earth fly you there. So it's going to take you to that location and wait until it stops moving, and although there is a pin there, it won't remember that pin unless we add one ourselves. So up here where the pin is, you're going to hit this plus pin icon. And because it's the first number in our list, we're just going to call it 1. And we want to say OK. And now there's a pin that'll stay there with the number 1. You can see it kind of sitting there. And we'll want to repeat that for the remaining 24. So we just quickly come in here, highlight, right click, copy, back to Google Earth, and paste this new location in here like this. Hit search for that. Let Google Earth center it. So don't click on the main map or it'll stop. And then once again we want to have a permanent space there, not this temporary dot that's there. We click it. We're just going to call this number 2 and say OK. And now there's a permanent dot there. And you will continue with this process until you have all 24 on our map. So we'll do this one more. Come back to Google Earth. We will copy and paste and search for that one. It'll slowly find that one. Remember, let it do its thing until it stops moving. We'll add number 3 here, call it 3, and hit OK. And so you're going to go through that process to add all of these locations in. Okay, so, and here's some more kind of tips on how to do that. So now, using Google Earth, we go back to Google Earth, it's asking for the maximum inundation, which means which point is farthest from the coast. Now, of course, as I zoom out, so I'm going to use my scroll bar and my mouse. It allows me to zoom out, but you can certainly use this minus key that'll let you zoom out. And you can see that the coastline is right here. We've only got 3 points in, but in theory you should have 24. And so once you take a visual scan of the area, you should be able to see which points are farthest from the coast. There'll be some that are right here, some that are back here. Now, it might not be obvious which one is the farthest, so you might have to take a couple measurements. And how we want you to do that is come up here to this little icon, which is the ruler tool, and click on it. And you can choose what units you'd like to use. We'll use kilometers. Remember, we're comparing. So at this point, if we go back to our question here, it says give the location of where the number, right? Is it number 1, number 2, number 3, all the way to 24? So we're not giving a distance yet. But, oh, we look here. Just kidding. Miles. So let's do that. Okay, so let's go back and change this to miles, because eventually we'll have to record that value. And then find the coast. So where does the water and the land meet? And so click here once, drag it to my point where the dot goes into the map, and it's about 2.17 miles. Okay, we can zoom in a little bit to maybe be more accurate. If we're not sure if that's the farthest one of the ones we have, we can clear it, zoom back out, and let's measure from the coast to the number 2. And it's 2.14. So currently, for us, of these three, the third one is the farthest. So we would come back to our lab and say, I'm going to put number 3 here. Okay, so that is my answer for that one. How far was it? Oh, well, it was 2.17, and we just want the number, not the word miles. Okay, and then you're going to do that. What's the closest one? Once again, you're going to kind of zoom out and get a visual look at all of your 24 dots. And there'll be a few that seem pretty close. You may have to go to each one and do a quick measurement. Come up here and say, okay, click to click. If there was a dot here, oh, that's 0.48 miles. Oh, how about this one over here? Oh, that's only 0.19. So you're going to find the one that has the shortest distance, which is the smallest inundation. So that would be the minimum. And so you'll put that number of the pin, 1 through 24 here. And then, of course, you've measured it, so you can tell me the value in miles, and you'll put that there. And so most of the remaining part of the lab using Google Earth is just measurements. There is some math in here, and here are the math equations that we're asking you to use. A rate, how fast something is, how far away something is, and how fast something can arrive. So, of course, our wave is generated at our epicenter, and that epicenter we can measure from that distance to where a location is. And so that gives us a distance, and if we have how fast the wave is moving, we can then figure out how long it took to get there. So here is one of those calculations. It tells you when the earthquake occurred. So this is military time. So 1446 is really 2:46 in the afternoon. That's when it first started. The wave hit this location, this power plant, at 15:15. So the difference in minutes, because that's what we're asking for here, is we have to add 14 minutes to make this the next hour, so 1500 or 3 o'clock. And then another 15, so 14 plus 15, it would be 29 minutes. So we would put that in there. In hours, how do we do that calculation? We're just going to take our minutes and divide by 60. It'll give us a decimal, and we'll plug that in there. Okay, and so because we know now how long it took, if we know the distance, so I know how long it took because I just figured that out in hours, right? A fraction, a decimal. And if I know the distance, I can tell you how fast that wave was traveling. And that can be useful for doing these other calculations. So if we go back to our map, or let me scroll up here really fast to our data. And so here we have all of our data. Those are our inundation points. Here's the epicenter. We need that, right? We have to include this in one of the plots because we're going to measure how long or how far it is. So I'm going to copy this, take it back to my Google. I'm going to clear this out. I'm going to, just like I was putting those points in, same process. We're going to do a search. And we don't like that. Okay, so let's go back and make sure that I did this right for you. So 38, 142, somehow I got 140. So my mistake. So you want to be aware the epicenter happened in the ocean. I'm going to go back to here. So there was a little error. And make sure I copy that. 142 it should be. Come back here. Right click. Paste. There's the 142. And search that. Oh, that's a lot better. And so out in the ocean here, this is where the epicenter occurred. So the wave was started here. Let's put a little dot there. So we're going to add the place mark up here with the icon. And I'm going to call it Epicenter. You can call it whatever you want, but this will help us remember. And say OK. Now, it asks you to use this as the starting point. I'm zooming out so I can see both the epicenter and my coastline. So the wave traveled from here and hit all these different parts of Japan. And we determined how far some of the waves traveled in along the coast here. So that was in the previous exercise. For this question here, as I come back down here, it wanted to know the coordinates of the epicenter. We just put that in. How far is the plant from that? So we want to search this Fukushima nuclear power plant. So if I highlight this and copy, just to make it easy, come in here and paste it and do a quick search, it should take me to the power plant. You see that little dot there. Okay. Now I'm not going to let it locate on its own because I can. So that's the, okay. We have to be aware, right? Fukushima. This is the, I am not sure how to pronounce that, to be honest with you. That's not what I want. I want this one, B. I'm going to click that one. So you just have to be a little careful when you're putting things in. Nothing's perfect here. But here is the Fukushima. This is the one that was impacted by the wave that had a nuclear meltdown. And so what I want you then to do is zoom out so you can see both the Fukushima. Come back. We're zooming out till I can see the epicenter. So I'm zooming out and then moving over and zooming out and moving. Oh, there it is. I want to know the distance from this point to this point. So I'm going to kind of center it, zoom in as much as I can without it leaving my page. Go back to my ruler tool right here. Okay, come up here. I'm going to go check and see. It says how far is the plant in miles, just to double check. So I'm in miles. I'm going to click to where the pin enters the ground there as best I can, right? And then come all the way down to here and click as close as I can to the coast. And there's the map length, the distance. So I'm going to come back here, 95.56, and I'm going to plug that in here. Okay. Now, because I know the distance right there, and we just calculated the time up here in hours, it was in a decimal form, I can plug those two things into this equation right here. And I'll know how fast the wave is in miles per hour, because I measured in miles and my time was in hours. So that's a speed for me. So we can keep doing this, right? What is the distance to the airport? So we can go back, copy and paste the airport location, find it, and then how long did it take to reach here? Well, look, I have a rate. I just calculated that in the previous question. I can measure the distance because I can use my ruler tool. Now I'm going to take the distance and divide it by the rate that I calculated, and it'll tell me how long it took the wave to hit the airport. Right, so this is what this first part of these calculations are asking you to do. Those are the tools that we're asking you to use in Google Earth. So you're relying mostly on the ruler tool and this little icon place mark. So remember to copy and paste in this upper search bar. Let the program locate that. It'll find it and put it in the center of your screen. So don't click on the screen while it's actively moving. Once it stops, if you hit the plus mark, it'll put a place mark exactly at that point. You can call it something, and for the first ones, it's just the numbers 1 through 24. And then click OK, so it'll save it, and then you can move on to the next one. And you'll have the epicenter. You'll have those points. You can start doing some measurements and things like that. And after that, it's just using the ruler tool, the search bar for a few locations, and of course zooming in and out so that you can see all the features that we're asking you to see. The remaining questions are using some math, but it's the calculations that are given here, that if we know the depth of the ocean, and this is a constant, so this doesn't change, we can plug in those values and it'll give us a speed. Now remember, meters, this is in meters per second. So the units are different here. Instead of having miles per hour like we did before, we're going to get meters per second. And so what it's doing here is asking you to do a calculation like that. But we want to change it because here in America, of course, we're used to miles per hour. And so we want to be able to do that in miles per hour instead of meters per second. So this is a conversion. And you can click this link. It'll help you convert. So we want to change things from meters per second to miles per hour because that might be a little useful for us. And then we can then figure out distances again. Find these locations. You're going to highlight them, copy and paste them in the search bar in Google Earth. Find it, and we know the epicenter, and you're going to click and drag that line all the way to this location, and you'll know the distance in miles. Okay? And then, once again, if we know the rate, we just calculated that in the previous questions, we can then figure out the time it took to get there. You measure the distance to Manus Island, and we did a rate that we converted from meters per second to miles per hour so that the units are correct, and then you'll be able to tell me how long it took to get there. And you'll do that a couple more times for different locations. Okay, so that's the lab. I'm not sure if that answers all your Google Earth questions, but if you can also send me some emails if you have some specific questions about Google Earth, and I can answer those in a video also. The last thing I think related to this lab was that I wanted you to find some locations where there was some damage caused by the tsunami. And so, of course, closer to the coast is where you'd probably see some damage. So what that is asking, and this is in the second part of the Tsunami Lab, is to look at some locations where you see structures that's fairly close to the coast and come to this icon here, which is Historical Imagery. If you click that, it'll allow you to go back in time and see what this looked like potentially before the tsunami hit and then after the tsunami hit. What I want you to do though is, you can see down here where it has 3D buildings. See those little blocks? It's kind of covering my buildings, so it's hard to see if they were damaged. So I'm going to uncheck that so that they're not covered. Now, this is from the date March 18th, 2020. According to that, wow, that's today. Holy crap. Okay, so we want to go back to when the tsunami occurred. Now, some of the imagery, like this, isn't useful for us, so we can't really look at that. So we want to go before the impact and then after. So this is after the event. We can see, like, holy crap, that's an image that shows some of the damage, and that's a pretty good image to show the damage. So we're going to try to get one prior to the event. Wow, that one's also pretty. No, we can't use that one. Keep going back till we get before the tsunami damage. This one, not so much either. So there's a lot of pictures before, so we're still going back in time. Still going back in time, can't use that. So we might have to use this one. Even though it's 2 years, we can see, and once again, we can turn off something. The roads are clouding my image, I take that off. So here we see homes, intact, roads, lovely farmlands and things like that. You can capture this picture here by clicking this Save Image button. And so for part 2 of the Tsunami Lab, it asks you to find any location you like. I'm just recommending you find one near the coast. And it also has to show the difference between before and after when there was some damage. So if you click this, it'll allow you to save the file. It'll save a copy of this image that we're looking at. Save that somewhere on your computer, you can find it. And then that's your before photo. And then come back until you can see a clear image of the damage. This one will work. You can capture this in the same way. This will be your after photo. So you'll upload a before photo, you'll upload an after photo, and then the third part is to describe what you see, the damage here. And so that would be some of the features that we can use. The go back in time, that's this icon. The capture some images, that's this icon. We went over the ruler tool. We went over the place mark tool. So hopefully those things will help you with this lab, of course, and then with any future labs. But if you have questions, feel free to email me and I can make a quick little thing here. Okay.